Okay, so in this demo, I will be showcasing my ZTP-like setup for Arista CEOS devices. This automation allows devices to be configured automatically through DHCP and a custom Python script. Due to limitations with ZTP support on CEOS, I developed a workaround using DHCP and a configuration script. I will talk a little more about why I did this at the end of the demo. Before starting the demo, I want to note that R6 and R7 are already connected in my container lab setup to save time. R7 connects to R6 via the Ethernet 2 interface, and R6 connects to R4 via the Ethernet 1 interface. This is a basic container lab setup, and I can show you. As you can see here, this is a basic container lab setup with no additional configuration in place. There are no IP addresses or DHCP relay or OSPF or RIP configured. The same with R7. There's nothing configured here as well. Okay, another thing to note here is that I made an assumption that the MAC address of R6's interface connecting to R4, which is this one, and R7's interface connecting to R6, the MAC addresses of these are already known, and hence I've configured the same on R2's DHCP server. I have to manually kick in the DHCP request packet from each of the devices, which is R6 and R7, because CEOS by default does not have DHCP interfaces configured. Okay, so first I will kick in my custom ZTP script, which is ztp.py, and I will talk about it in a bit. This one initiates the automation process. So this script continuously checks if my devices R6 and R7 have obtained an IP address and become reachable on the network or not. So this script pings each device until it's reachable. As you can see here, I'm running ping -C1 IP address, and the IP addresses are basically retrieved from this dictionary, as you can see here. And once a device gets an IP address, this script automatically connects via SSH and applies its configuration. This includes setting up IPs, routes, DHCP relay functions, etc. Now, this configuration for each of the devices are retrieved from two config files, which I will show you in a bit. But as you can see, I'm using netmiko to push the config here. There is a function here, and there is a file that it takes as an argument, and I'm going to show you how that file looks like. And it just pushes the file once an IP address is detected on R6 or R7. So these are the two configuration files, and this is R6 underscore config.cfg and R7 config.cfg. Both of them are managed in Git for version control, and these files are used to push the respective configurations to each of the devices. Now I will open R6 config.cfg. Ethernet 1 is this particular one that connects to R4, and it has an IP address that's configured. Then there is router OSPF1, and what it does is it essentially forms OSPF neighborship with R4 and is advertising this network connected to R7. One thing to note here is that this IP address that I configured was needed, which I will show you in a bit, although I am taking the IP address from the DHCP server, but for some reason it just does not show up in show IP int brief output, and OSPF neighborship does not get formed without this IP address. So I have to like manually go and set this up. The other thing that I'm setting up is DHCP relay options, because R7 also needs an IP address. R6 is the relay agent, and Ethernet 2 is basically this side, which connects to R7. I'm configuring an IP address and a helper address, which is the DHCP server, which is R2's IP address. Lastly, I'm configuring RIP, and this network is this network which connects to R7, and it's forming RIP neighborship with R7. Let's see R7's configuration. This is just the interface that connects to R6, which is obtained by DHCP, and similarly I have RIP here that's forming neighborship with R6. Now note here again, I had to manually configure IP address 192.51.06, although this is still being obtained by DHCP server, and I will show you what I mean by that. Before I get into the entire automation process, I just want to clarify this part where this was supposed to be obtained by DHCP server, but why I'm manually assigning it here. So this is R7. I'm just gonna log into R6 actually. So this interface Ethernet 1, this interface's IP address is supposed to be obtained by DHCP server. So I'm gonna go to the bash prompt, and as of now there is no IP address configured. So I'm gonna do a DH client Ethernet 1, which basically would send the DHCP request packet. And if I do config Ethernet 1, and as you can see now there is an IP address configured, and before there was no IP address configured. This is 192.51.02 that I have assigned. But now if I go back and if I do a show IP int brief, this particular interface IP address wouldn't show up, although this IP address would still be pingable. But as you can see, there is no IP address on the Arista. I'm not sure if this is a bug or not, but this is the reason why once my script, what it does is once the IP address is pingable, it will send manually this command. Okay, so I'll go back to bash and I will clear the session again. So if I do nfconfig ethernet 1, I will have to manually remove the IP address. Config ethernet 1, and as you can see there's no IP address now. Alright, now I'm gonna kick in my automation piece, which is ztp.py. Now ztp.py pings each device until it's reachable. As you can see in the script output, it says that R6 has my script can't currently ping the IP address of R6 and R7, so it's reporting them as unreachable. It will retry every 3 seconds until the devices become reachable. Okay, so now I'm gonna log into R6 and request an IP address from the DHCP server like I did before. So I'm gonna do a DH client Ethernet 1, and as you can see here, Ethernet 1 has an IP address. And now if you see the log here, it says that R6 configuration was applied successfully. This includes enabling IP routing, setting its IP address, and configuring it as a relay agent for R7. Let's see how it does that. If you can see here, the OSPF neighborship is configured, RIP is configured, interfaces IP addresses are configured, and DHCP relay is also configured. So if I do a show IP OSPF neighbor, it is forming a neighborship with R4, which is 200.0.0.2. This is R4, and 200.0.0.2 is the highest up IP address on R4. That's why that's the router ID. And for now, there is no RIP. There are no RIP neighbors because R7 is yet to have an IP address configured. Alright, so similarly, I'll do the same for R7. I will manually send a DHCP request packet, and how I do that is by running dhclient in that. Okay, I'm gonna run this again because sometimes dhclient needs to be run 2 times for some reason to get an IP address. Oops. Client. Okay, I just ran that script again, and if you see here, it has an IP address configured, and my script also successfully completed, and it says configuration applied successfully for R7 as well. Now I'm gonna go back to R7's prompt and I'll do a show run, and if you see here, it has a RIP configured and it has an IP address on Ethernet 2, which is obtained by DHCP server. And if I do a show IP RIP neighbor, now you can see that R6's neighbor is up. Okay, so this is how I enabled ZTP. Now I would like to talk about the troubleshooting steps and workarounds that I did. And before starting, when I was starting this video, I had explained about some issues that I had come across while enabling ZTP. So I encountered several challenges while setting up this ZTP process on the CEOS devices. The first one was setting up TFTP transfer limitations. So I attempted to set up a TFTP server on Ubuntu, which is this NMAS, to serve configuration files. I configured DHCP option 66 to supply the TFTP server details on R2. I can show you that as well. As you can see here, I have it configured, and I've also given the server file name here. But the CEOS devices, all of these R2, R4, R6, and R7, did not initiate the expected TFTP request. I verified that the TFTP server's port, which is 69, was open and allowed that traffic, but the devices still didn't retrieve the file. And I did a quick TCP dump on R6 and R7, and I saw that neither of these devices are requesting for option 66, which is the TFTP server, and hence R2 is never even providing that detail. So that's one of the problems that I faced. The second one was I tried to use TFTP to manually transfer configuration files. So basically, I was transferring from my Ubuntu, which is my NMAS, to R6 and vice versa as well. And I saw that the files were getting created on the device, the receiving device, but the contents of the file did not transfer successfully. I tried multiple solutions to resolve this, but none of them worked. So I just switched to using NetMiko. As you can see, I just resolved to using ztp.py for configuration instead. The third problem that I faced was unsupported ZTP on Arista CEOS. So CEOS does not support native ZTP, so the zero touch enable command could not be used. As you can see here, if I do zero touch enable, it says zero touch cannot be enabled interactively. To enable zero touch, delete the startup config and reload the switch. However, I can't reload the switch because it is not supported on this platform. So after researching, I confirmed this limitation, and um, one particular article on Arista mentioned that CEOS does not natively support ZTP, and thus I created my script, which is ztp.py, to simulate ZTP by detecting device availability and applying configurations via SSH. Thank you.